What's going on, geometry? You guys better be behaving. Okay, we got section 5.4 today, medians and altitudes. Alright, we're still continuing our super fast pace here through chapter 5. We're going to look at medians and altitudes today. Tomorrow we're going to have section 5.5, I believe, and then we're going to call it a chapter. Practice, test. So you're going to test on Thursday with this then. Alright, we got one slide of definitions. Guess where these are all out of? That's right, the book. Okay, median of a triangle. Okay, a median is a segment from a vertex to the midpoint of the opposite side. Okay, from a vertex to the midpoint of the opposite side. So a little bit like perpendicular bisectors, but also different. Centroid is the point where the three medians would cross at. It's the point of concurrency for the medians, called the centroid. Special cool little thing about the centroid is that it is the center of mass. Okay, we could balance a triangle on a pencil tip right there on the centroid, and it would balance for us. Altitude of a triangle. An altitude goes from a vertex and makes a right angle or is perpendicular with the opposite side. So these are very, very closely related here. One's going from the vertex to the midpoint, one's going from a vertex, and it doesn't matter where it goes through, just as long as it makes a right angle. And with obtuse triangles, sometimes you have to extend out the base. There's no way I could go from this corner and hit the side of the triangle over here and make a right angle. Okay? Imagine if this was like a dirt bike ramp. Okay? And we're going up the ramp this way. You wouldn't measure how high off the ground the ramp is from going from here back to here. Okay? You'd measure straight down off the ramp. So that's why we have to extend out that side of the triangle. And all three altitudes cross at the orthocenter. At the orthocenter. And there's really nothing cool about the orthocenter. It's pretty boring. Okay, so if there's something on a quiz or a test, there's nothing cool about the orthocenter. You don't want to guess that one necessarily. Alright. Concurrency of medians. Okay, the medians of a triangle intersect at a point that is 2/3 the distance from each vertex to the midpoint on the opposite side. Okay, the medians of triangle ABC meet at point P, and A to P is 2/3 of AE. Alright, so we'll go through an example here with these side lengths. This makes it pretty complicated. This is actually pretty easy. And this will be pretty easy stuff to do here. Very similar to kind of like mid-segments. Alright. Concurrency of altitudes. Lines containing altitudes of a triangle are concurrent. They meet at the orthocenter. No special formulas with that. Okay. Turn in the page. Alright, so we have triangle RST. Q is the centroid. Q is the centroid. Okay, S to Q is 8. Find QW. Alright. So what happens here is that it splits up that whole segment into 2/3, 1/3. 2/3, 1/3. Okay, what's the relationship between 2/3 and 1/3? Okay, well you could say 1/3 is half of 2/3, or 2/3, okay, would be twice as much as 1/3. So if this one's 8, okay, we cut the big piece in half to get the little piece, 4, and then my whole SW there would be, the whole thing would be 4 plus 8, 12. Okay, so the big piece was 8, the little piece was 4, and the whole thing would add up to be 12. 12 times 2/3 is 8. 12 times 1/3 is 4. Okay? If they give you the big piece, cut it in half, that's the little piece, and then add up to get the whole thing. Alright, if they give you the little piece, double it to get the big piece, and then add them up to get the whole thing. Alright, if they give you the whole thing, I would divide that by 3, do the 1/3 first, that gets you your little piece, and then double that to get the big piece. So that's how I would do it. Okay, we have a centroid. RS is 4, WV is 6, and T to V, it's always tough to figure out where you want to put that when it's the whole segment, T to V, where you want to put that. Sometimes I put that up here in the corner. That's 9. Okay, so let's go in order here. They gave us RS first. RS appears to be the big piece, so we should do what? Cut it in half to get the little piece, 2, and then we add up to get the whole thing, 6. Okay? Well, remember what these are. These are medians. The centroid is the point of concurrency for medians. Medians go from the corner or the vertex to the midpoint. So if this side is 6, this side is also 6. We're going to throw in another number right here just because. Whew, that was close. That was 6 blank, 6, 6 for a while. We had to mess that up. That 1 doesn't mean anything. That's just there to block that. Alright. What else we had here? We got this 9 up here. 9 is the whole thing from T to V. 9 was the whole thing from T to V. So when we have the whole thing, I suggest dividing by 3. That gets you your little piece. Once you have the little piece, you double it to get the big piece. Double check. Does 3 plus 6 add up to 9? You bet. Okay. Now he can go through and answer these questions. RV, that's 6. SU is the little piece. That was 2. RU, that's the whole thing. 2 plus 4 was 6. RW, that's the whole side. 6 plus 6, that's going to be 12. TS, that's the big piece there. We said that was 6. And S to V, little piece. We said the little piece was 3. Okay, onward. No, we'll move on. Where is the center of the isosceles triangle, and why is it the center of the isosceles triangle? Okay, so we have an isosceles triangle. Alright, so far we have midpoint to vertex. What if we go midpoint to vertex here, and midpoint to vertex over here? Okay? Well, it's probably supposed to land like right there. Okay, so I would say that our center, if you go by the centroid, the center of mass, is going to be on, and for the isosceles triangle, this is going to be a perpendicular bisector. It's going to be right here down the middle on our first one there, on the perpendicular bisector of the vertex angle side there. Another kind of weird question to have in there. I didn't think you'd want to do the coordinate one, so we skipped that one as well. Okay, these are the types of problems you really need to know how to do. Alright, B to G is 9. What is B to F? If B to G is 9, that's the big piece. Half of the big piece is 4.5. They're trying to get us with a decimal. So 9 and 4.5, the whole thing, BF, would be 13.5. Okay? Remember, these are centroids. The centroid is the point of concurrency for medians, which go from the midpoint to the corner. Midpoint to the corner. So if B to D is 12, and D is a midpoint, this other side is 12, A to D would be 12. C to D, whole thing, is 27. Okay? 27. So when it gives you the whole thing, I suggest dividing by 3. 27 divided by 3 is 9. That's the short piece. Okay, double that. 18 is the long piece. What is G to C? That was the long piece. 18. Alright? That's the game plan there for centroids. So we're going from corner to midpoint. Okay? If they give you the little piece, alright, if you're given the little piece, then you want to double that to get the big piece. Then add for whole thing. Zoom out. If you're given the big piece, divide by 2 for the little, add for whole thing. What if you're given the whole thing? Then we divide by 3 for little, and then we double the little for the big. Alright, there you go. Okay, as you can tell, the sub is probably playing this off of YouTube. So if this was too fast for you, or you forgot what you're doing when you get home, where could you find this? YouTube. Okay, search for Handke geometry, and whatever section this is, 5.4, 5.4, Handke geometry, section 5.4, and you'll have all that there. Okay, all those vocabulary and theorems and stuff at the beginning. Again, those are all right out of the book. So if that was too fast for you, okay, you could go online, look this up, and then hit pause right now. Or you could go into the book and find those exact bolded words and diagrams. Okay, you guys got quite a bit of time here to work on your assignment. It's the same one as on your homework slip. We have page 324, 1 through 10, 13 through 27, 34, and 35. Okay, I'll take another look at those here today, Sunday, after the Vikings just won again. Woo, go Vikings. Okay, I'll take a look at those here real quick again to make sure those are all good. And if I find a bad one, I'll have it written on the border in the subnotes to skip one of those. But as of now, that's what you got. All right, we'll see you tomorrow.